Hey, 8th grade. Hope everybody is doing well. I got some messages last week that said that the video that I posted helped a lot of people with their packets, so I'm going to try to do that again today. I will tell you that I graded your first assignments that you sent in at the end of the week last week, and some of you are doing great. Some of you are doing better than you were in the classroom. However, I do have some people not turning their stuff in or not taking their packet seriously at all. A lot of you did not go read your instructions, and you know, on those warm-ups, sometimes those instructions are critical to getting the answers right. Having said that, please make sure that you're reaching out to me if you need some help. I get back to everyone almost immediately. Everybody that's on Remind, there's no reason that you can't just pop a picture and ask me a question. I'll be more than happy to help you. I know some of your parents can't help you. That's perfectly fine. That's what I'm here for. I'm still getting paid to teach you. So let me help. Let me help if there's anything I can do at all. All right, having said all that, I'm going to go through the packet starting on page 25 and kind of go through the end with y'all. Some of the questions I'm going to give you some little hints on to try to help you. Others I'm not going to go through because they should be relatively simple. So starting with number 1. Some of you may be having a problem with number 1. I did as well when I started reading it because it asks you about the subatomic particles in the dark gray area. So there's 2 dark gray areas on the picture, and it's hard to tell depending on your copy which one's the darkest. So one of the subatomic particles that is in dark gray is inside the nucleus, and then you have your layers around here, which are also dark gray. So if you'll just let me know which one of those particular particles that you're calling dark gray and choose the answer from there, I'm not going to count it wrong. Obviously, this is not your fault, and it's hard to tell dark gray because everything on the picture is dark gray. At the bottom, it's asking you some characteristics of protons, neutrons, and electrons. And I know it's been a while since we went over those. I'm going to try to show you a picture of my journal. So remember, oopsie, this page is kind of difficult. Okay, and then when you hold it up, it has the mass of each one of those subatomic particles, and that's going to be important to you in answering that question. So next page. Starting with the next page, you are going to have to use your periodic table for this. Remember that one of your subatomic particles is also your atomic number. So make sure that you're using your APE to figure that out. That's going to be really helpful for number 3. On the next page, you're going to have to know where your subatomic particles are located. So there's a small little diagram, but you should know that. You should be good with that. Moving on, I am going to, where am I going? Page 29. So go to page 29 and remember which one of your subatomic particles identifies your element. So remember that your protons identify your element because your protons are the same as the atomic number. And your atomic number, that's how your periodic table is organized, by increasing atomic number. So that is going to help you answer that question right there. Down at the bottom, it asks you again about characteristics of your subatomic particles. I want you to remember that even though we're drawing those, when we drew our Bohr models or whatever, everything was on a flat surface. But I want you to remember that those electrons are moving around the nucleus. So the nucleus is in the center, and the electrons are moving around it. So because the electrons are moving, they're going to have more energy than the protons and the neutrons. And so you're knowing that your valence electrons, your electrons that are outside the nucleus, are moving and have more energy is going to be critical for answering that question. All right, page 30. Page 30, you're going to have to pay attention to the groups that these elements are in. Okay, so I want you to look here and here. and make sure you're on the periodic table, looking at what groups those are in. And remember, in order for an atom to be, stable, that outer energy level has to be full. So if it's full, it's stable. If it's not full, it's reactive. Let's see. On page 31, number 4, you're going to have to look up the group number and the number of valence electrons to figure that one out. And then number 3 at the bottom, again, you have to remember that your protons are what identify your element, and your protons are the same as that atomic number again. Moving on to page 33, I don't have much written for you on page 33, but I do want you to make sure that you're marking out absolutely what you know is not true. And don't forget to use your strategies when you're doing that kind of thing. Also, starting at number 2 on the bottom, you have to know what a compound is, the difference between a compound and an element. So remember that a compound is just elements that have been bonded together because they're sharing those valence electrons. And remember that if you're looking at a formula, that everywhere you have a capital letter, that is a new element. So that's going to help you with that as well. All right, page 34. On page 34, this is a pretty detailed question. So in order to get this right, it's asking you about fluorine. So go on your periodic table, and I want you to find fluorine on your periodic table. And then you have to know the number of valence electrons that are in that element fluorine. And again, I want you to remember that to be stable, all of those energy shells have to be full. So when you find it on your periodic table, it's going to tell you how many valence electrons it has. And remember that if something has 7 valence electrons, it's going to bond with something that has 1 valence electron. So those things are going to bond together to make that last energy shell complete for it to be stable. All right, moving on to page 35. Page 35, number 4, has 2 answer choices that are exactly the same. Okay, so don't let that mess you up. You should still be able to get the right answer, but it has 2 answer choices that are the same. On number 5 is going back to your periodic table, and you have to be able to know where your metals and nonmetals and metalloids are on that page right there. Page 36, it's asking you for something that is chemically stable. So remember, if it's chemically stable, then its valence electrons are full on that outer shell. Page 37, and going back to chemical formulas, so that remember that your each element is going to start with a new capital letter, and every time that you have a capital letter, that's a new element. And then you're going to get down here where you're having to count the number of atoms. So remember to use your subscript. So remember that the subscript, which is that little tiny number, it only goes with the element that it's right after, that it's attached to, unless it's in one of those situations where you have a parentheses, and then the subscript goes with everything inside the parentheses, but you don't have parentheses on that particular problem. Next page, page 38. You can omit number 3. You can totally mark out number 3. We haven't really talked about hydrocarbons, so go ahead and mark that out. On the bottom of that page, number 4 is talking to you about aspirin. Make sure when you're answering the question that you're using the right formula, because there's more than one up here. Make sure that you're looking at the formula that the question is asking you about. All right, page 5. Page 5 gives you a chemical equation. So in order to get this right, this is not difficult, but I went and labeled each one of my products. Remember that, reactants. So remember that your reactants are what are the things that are reacting together. And then after the arrow are your new products. and that they're just rearranged. Okay, so in order to get this right, I went here and labeled what each one of those compounds stand for because it's easy to get confused. So I suggest you do that if you're working on this question. On the bottom, it asks you about aluminum hydroxide and aluminum sulfate. So same thing, just make sure that you're looking at the right formula. Here we have a subscript. You have two subscripts actually. So remember that this little subscript right here only goes with the oxygen, but this subscript on the parentheses, because it's attached to the parentheses, goes with everything inside the parentheses. I'm about to lose my battery on my phone, guys. All right, let's see. Number 7 on page 40. Number 7 on page 40 is asking you for the total number of atoms here. So what you're going to have to do is you're going to go count atoms of each one of these and then find me a total. All right, page 41 switches gears and talks about chemical changes. So remember that we talked about evidence of chemical change. You have to know what your evidence is of chemical change to get that correct. I did put it in the spiral notes that I sent earlier. Let me see if I can find it again in my spiral. And I'll hold it up here. I've got so much stuff in my spiral. I'm gonna check for you guys. Bear with me. I thought I put a paper clip on it, but evidently I did not. Oh, no, I did. Where is it? At the beginning. Come on, girl, get it together. Here we go. These are all your evidence of chemical change. Just remember that anytime you have a new product, you know that a chemical change has occurred. So anytime something new happens or something new is formed, you have a chemical change that has occurred. Same thing for the next few pages, all the way to page 43. Basically, all you have to know is there evidence that a chemical change has taken place or not? Then we get to page 45 and it starts changing a little bit again. So we're still working with equations, chemical equations. And remember that to have an equation that's balanced, it has to have the same number of each element of each atom. Same number of atoms of each element on both sides, on the product side and the reactant side, in order to be balanced. And also, you're going to get into questions that ask you if something follows the law of conservation of mass or not. So remember, if an equation is balanced, it follows the law of conservation of mass, because particles can't be, atoms can't be created or destroyed. They can only change form to make a new product. Okay, so whatever you started with has to be whatever you ended with if it's going to be balanced. They're just going to be rearranged in a different order. So again, the law of conservation of mass says that matter can't be created or destroyed. It can only change form. So same number of atoms of each element on both sides, on the product and the reactant side. All right, next page, page 46, number 3. Page 46, number 3 is asking you about a coefficient. So remember that a coefficient is the big number that goes in front of something. These here are subscripts. Okay, so a coefficient is going to be a big number that you would put in something else. And that coefficient goes to everything behind it. So basically it's asking you what coefficient would you put in here to make it balanced. It's not balanced right now. It's asking you what coefficient would you need in order to make that equation balanced. All right, then flip to page 47. We're almost there. Again, it is talking about having a balanced equation. And you're gonna have to work each one of these answer choices out to get this correctly. So this is how we did it when we were in class. So this is only the first answer choice. So I took each element on each side of your arrow, and I counted elements of each atom on both sides. And in order for that to follow the law of conservation of mass or to be balanced, they have to be equal on both sides. If you don't show your work and go through each one of those answer choices, you're probably not going to get that correct. All right, last one. On page 48. Page 48 is a bonus question. So you don't have to do it, but if you are, I'll give you some bonus points for that one. It took me a few minutes to figure it out. All right, guys. Hope everybody is doing well. Hopefully we'll get back to school soon. So I just watched a press conference a little bit ago, said there's a possibility some of us may be able to go back on May the 4th. I know some of you probably don't really want to go back to school, but I do. It's driving me kind of crazy being at home. Anyway, I still miss you guys. I hope everybody is doing well and staying safe. I'll see you next week somehow.